Hello everyone and welcome to the last day of Sequences in Series looking at summation. Now what you need to do right now is pause it and read these 4 bullets and try to understand that. So you're going to pause it now and read those 4 bullets. And so here we go into the mathematical portion of it. The summation from 0 to 5 of k. So what we're going to do is we're going to write that out as starting at 0, plug in 0 for k. You're going to get 0 plus next numbers 1, 2, 3, 4, and 5. Why do we go from 0 to why do we end at 5? Because we end at 5. This is our lower and our upper bounds. With that, we're going to now add them up. 1 and 4 is 5, 2, 3 is 5, so we're looking at 15. Next one, we're looking at the summation of j squared from 5 to 7. 5 squared plus 6 squared plus 7 squared. 25 plus 36 plus 49 equals 110. So, again, the idea, you have to know your bounds. And you got to know the function that we're looking at. Moving on. C. Again, starting at 2, so we're going to have 1/2 plus 1/3 plus 1/4, again, ending at 4. When you add that up in your calculator, you can get 13 over 12. So that's the idea of summation and how you do that. If you got confused, go back and reread those first 4 bullets. The next part is actually writing the summation. So we always have to write out, that's bad. We always have to write out the summation formula, or the summation, the Greek sigma. Notice here, 1, 2, 3, 4. What changes is the base, x. What does not change is that it's raised to the 4th power. It starts at 1 and goes until 9. Done. That's it. If we look at this one, okay, we notice that cosine of 0 pi equals 1. Cosine of 0 is 1. If you remember, if you don't remember, where cosine of 0 is there, and that's the point 1 comma 0, so cosine of 0 is 1. That's why that's there. So what doesn't change is that there's cosine of pi. That doesn't change. And the numbers change, so we're going to put an n there. N starting at 0, that's this one, and ending at 5. Now with this, there's a reason why, you'll see throughout here, there's a reason why we did the first 3 lessons before going here. You'll notice that this is an arithmetic series. We have our first term at 2. Our difference is 2. We need to know what our last term is. We know our the term, because we know the value is 1,000. So over to the side, we have to find that out. 1,000 equals 2 plus 2 times n minus 1. And we have the n minus 1, we didn't start at 0. So we're going to get 998 equals 2n minus 2. We're going to get 1,000 equals 2n, and we're going to get n to equal 500. Now we know that when we write out our summation, we're going until 500, starting at 1. So we're going to just write. Now this is something that people make a mistake on. When you have an arithmetic series, all you're going to do is write out the arithmetic series or sequence formula. Our starting value, we know our rate of change or the common difference, n minus 1, from 1 to 500. Just to make sure we're right, we plug in 1, and 1 minus 1 is 0, so we start at 2. Go to 500, 499 times 2 is it's 998 plus 2 will give you 1,000. So, when you have an arithmetic or geometric sequence or series that we're adding up, you just write the formula as the summation. why don't you guys do A through D, just trying it out here. You're going to go, write them all out, and then go from the lower bound to upper bound, and then actually find the summation after you've written them out. Good luck, and I'll come back with the answers. And hopefully you read that you do not need to find the sum. So, first two here, the pen and the program aren't working well, but know that this x to the 0 can be written as 1. So the x to the 0 would go away, and then you would get plus x to the first plus x to the second. Again, as I said, it's not working great, so it's flipping. But know that x to the 0 could be 1. The next one, again, it's not working great. You get x to the 0 plus 2x plus 3x squared plus 4x cubed. Know that x to the 0 can just be written as 1. And so know it should be 1 plus 2x plus 3x squared plus 4x cubed. In the last one, I didn't finish it because I wanted you to see this. Anything to the 0 power is what? 1. So we're going to get 1. Negative 1 to the first is minus, is a negative 1 times x, so it's just going to get x. Negative 1 squared is a positive 1, x squared. Negative 1 cubed, a negative 1, x cubed. Notice that we don't have to write the 1's out in front. So what we're going to get here is 1 minus x plus x squared minus x cubed plus x to the 4th minus x to the 5th plus x to the 6th minus x to the 7th plus x to the 8th minus x to the 9th. So just realize that that negative 1 just alternates between 1 and positive 1. You saw that in the geometric sequence notes and homework. So the next one is we're going to write each sum using summation notation. So instead of what we just did was by writing it out, we're going to write the summation. We're not going to do all of these, but again, the key is that you have to notice 1, is it arithmetic? 2, is it geometric? So in this case, it's arithmetic. Our A1 equals 1. Our D, common difference, is 1. And what is our AN? Well, our AN's 1,000, but what is our N value then? And we've got to figure that out. If that means you go into the side and doing, okay, 1,000 equals 1 plus 1 times N minus 1, and then you're going to get 1,000 equals 1 plus N minus 1. Those cancel, so N equals 1,000. And again, many of you could see that without, because we're just adding 1, but that's how you would do that. So summation notation starting at 1, ending at 1,000 of N. And when you do this, you need to make sure that you label your variable here. So if you use N, you have to have N equals 1. That's it. You could have put, you could have done this, which I probably would have liked better. Starting value of 1 plus 1 times N minus 1. That would have been the correct arithmetic sequence formula for that. Either one works though. So let's look at B. Notice that we have our A1 to be 2, our common difference to be 2, our AN equals 100. Well, what is N then? Well, if we go to the side, we have 100 equals 2 plus 2 times N minus 1. And again, if you did this out, distributing the 2, you saw that these 2's canceled, and you would divide by 2 to get 50 to equal N. So we're going to start at 1, go to 50, and again, I'm just going to copy that down. When you do the work, it's going to help you out. 2 plus 2 times N minus 1. You can always plug this in the calculator. Okay? Always plug this in the calculator and go to the 50th term and see if it's 100. You can always check it that way. C, let's look at C here. Our A1, again, we're looking at arithmetic sequences here. A1 equals 1, common difference is 2. Our last term is 99. What is N? So again, we go to the side. 99 equals 1 plus 2 parentheses N minus 1. It should be getting to be old hat for you now. 1 plus 2 N minus 2, so that's going to be negative 1 add the 1, get 100 to equal 2n, and therefore n equals 50. So when we're writing out the summation, 1 to 50 of this formula, or that equation, excuse me. Done. So I'm not going to do all of these right now, and I'm going to have you practice some, but notice what's happening here. 1 to 2, 2 to 3. It's a fraction. You start to get confused. Don't get confused. You have to look at the top, the numerator, and the denominator. They can have different patterns. In this case, they do not. So we have a fraction, and how do we move? Well, we start at 1, we go all the way to 99. So we know we're going to go n equals 1 to 99. And I was just noticing mistakes that I made at the beginning here. Make sure that we have n equals on those summations. So do not mistake that. That is a very important part. So 1 to 99 is just n. If I plug in 2, I should get 2. Plug in 3, I get 3 on top. How does the bottom, the denominator, differ from the top? Well, 1 to 2, 2 to 3, 3 to 4, 99 to 100. It's just adding 1. Done. That's it. Why don't you guys try E, F, G, and H. See what you got. Hopefully starting to become a little more obvious to you. So pause it and try E, F, G, and H. And when you unpause it, it'll be done. And hopefully you have it done too. And so here are the answers. The one that you probably had the most difficult one was with G. Notice that the numbers always go up, and the number next to the 3, or the number next to the denominator on the left, is always 1 more than. So it's n times n plus 1. So a number, and then 1 more than the number. The numerator never changes, guys. The numerator is always 1, so we just keep 1 there. Another mistake might have been on F, where F was the fact that the x never changed, so you got to keep x as the base, and then the exponent is the number that changed, that increased. Notice that you always start at 0. This is another way of saying x to the 0 right here. And so you got to always start at 0. You can't start at 1. So the final portion of it is finding the sum, finding the actual sum. Well, from last class you know what the sum formulas are, and so I will write them here for you. So this is another multi-step process. So we have a geometric series, so we know we're multiplying. 1 to 3, 3 to 9, we know that we're multiplying by 3, so r equals 3. We need to figure out, well, we know that our first term is 1. We don't know what term 2187 is, so we have to use our formula for that. 2187 equals 1 parentheses 3 to the n minus 1. And then using our calculator, we will get that n equals 8. And now, knowing that our first term and our ratio, we can find the subs. The sum of those 8 terms equals our first term times 1 minus 3 to the 8 all over 1 minus 3. Excuse me, I don't know why it's not working. And the answer is 3,280. I'm going to move quickly on this last one only because let's actually move right on to C. You guys can try B. Time's running out here. So notice that our first term is 1. Our ratio, notice that the numerator, or denominator, excuse me, is multiplying by 2 and the signs are switching. So we're going to go negative 1/2. We have to find what term 1 over 5/12 is. So again, we go over here and just write 1 parentheses to the negative 1/2 to the n minus 1. And we get, in the calculator, we get 10. And therefore, the sum of the first 10 terms is 1 parentheses 1 minus negative 1/2 raised to the 10 over 1 minus parentheses negative 1/2. And you get 341 over 512. So why don't you guys try B, and we'll see you in class tomorrow. Bye.